Hello, folks. Good morning on a Tuesday, March 2nd, and today we are here to bring you another of the great problems in programming. Classic, actually, it is the binary search, and we are going to have a lot of fun coding this problem. So, let's take a look. Given a sorted in ascending order integer array nums of n elements and a target value, write a function to search target in nums. If target exists, then return its index, otherwise return -1. And he gives an example here. The target is 9. As you can see, the index will be 4. 0, 1, 2, 3, 4. So as you know, it's a C and C++, they have this zero-based indexing, and I believe Python has it too. So it's 0, 1, 2, 3, 4. That's why the answer is 4. Same thing you could do here. In this case, the 2 is not found, so actually the answer should be -1. And I think he has this note where he says that all elements and nums are unique. I guess that's there for simplifying the issue, because if you have more than one, you might just return the one that you find first and then forget about the rest. So that might be a problem. So n will be in the range 1 to, I think this is, because I wonder why he gave this one. N will be, I guess if you take integer values, then maybe there are some implications to that, but I don't know. Feel free to comment in the comment section, but let's try to give it a shot. So basically what we're going to do is we'll use an iterative binary search where we start out with two indices, low and high, pointing to the extremes of the original input vector or array, whatever you want to call. And then, by the way, this is num size -1 because indexing happens from 0 to n -1. Now, with that caveat, let's try to see that what should be our condition. While low less than equal to high, what we do is we first calculate an element known as mid, which is low plus high by 2, right? Once you do that, then all you need to do is so basically you need to now look for the target. So if you know and if you have done your reading first before you start coding, which is always a good idea, the concept should be built first. So the concept of binary search is that if you have something like, let's say, some array which is like 10, 20, 40, 65, 95, if you have this kind of sorted array, to look for something is like looking something in a dictionary. You start going in the middle and then you compare the thing that you're looking for. Is it less or greater? If it is less, then go on the left, otherwise go on the right, and then you basically repeat this whole process. So how we code that? We say if target is less than nums mid, right? Then the high changes, right? High becomes mid -1. Else, if target is greater than nums mid, then low becomes mid +1. Else, we have our element, right? There can't be any other possibility. So either you got less or greater or equal to, then you can just return mid. and otherwise, when you come out of this while loop, you're supposed to return -1 according to the specification, right? So this should fix the problem. I think this should take care of. That's all we need to do. Now return -1. I see. Okay, so everything is looking good. Let's try to run this code. And there you go. And submit. And that works as well. So everything is looking good. I hope it was a gentle introduction to the subtleties of binary search. It's one of the probably most asked questions in the interviews. And the reason for that is that it's the classic computer science basically. So you look at uh, the the search, and within search you have the binary search. So you have the binary search where you kind of divide the space in which you're looking for by half every time. So what's the time complexity of this? Why people prefer binary search? Because if you think about it, if you continue to divide by half every time, your time complexity comes out to log n, right? Because every time it is divided by half. So and log n is a great search, because think about it. If you had an element of 1024 element array, it will only take you how many iterations to find out if the element exists or not. So if you take log 2 of 1024, you get what? 2 raised to the power, I think 9 is 2 raised to the power 9 is 512 if I'm not mistaken. So I think 2 raised to the power 10 is 1024. So in 10 iterations, 10 attempts, you can find if the element exists or not. So so for the case of, for example, 1 million, how many attempts? So that is an exercise. I leave it to you, and please comment that in your comment section, and feel free to subscribe the channel, and point out if you see any issues or if you see any problems we should solve. We will actually love to hear from you. So with those words, I leave you guys alone to do your own problems, and I will see you in the next video. Take care. Bye bye.